Good morning. Thank you for joining us today for our annual conference, Smart Cities Miami. We are honored by the presence of Provost Samuels, who's going to launch the conference. I think this is his first Smart Cities Miami conference, and we are grateful for his participation this morning.
Thank you, Rudy. Great to see you all. This, by the way, is the most comfortable setup I've ever seen. I want to be a panelist just so that I can sit on these chairs. It's wonderful to see you all. I'm so glad to be here this morning with you for the 10th Smart Cities Conference. I, as many of you may know, just joined the university 8 months ago. I came here from Columbia, South Carolina, a city that does not have smart city conferences yet, is not of this scale. But I'm really thrilled to be able to open this event. I'm very sorry that I had hoped to stay for a while this morning to hear the conversation, but something came up over on the main campus that I need to get back to. But it was very important to me to come over just for a few minutes to welcome you, to open the event, to talk about this extraordinary partnership among the School of Architecture, the College of Engineering, and the Frost Institute for Data Science and Computing. It's really, to me, a signal of the excellence of the impact we want to have, that this conference is now in its 10th year. And one of the themes that I've heard during my time here that's been very heartening to me, and that I hope in my role to be able to amplify across our university community and indeed more broadly across Miami, South Florida, the state and beyond, is the importance of interdisciplinary inquiry. The importance of it as it relates to research, as it relates to our undergraduate mission and our graduate teaching mission. And to that end, and some of you have heard this now multiple times, depending on what events you've attended, I'll be creating an office of interdisciplinary programs in the Office of the Provost, led by a Vice Provost for interdisciplinary and international programs. We'll be one of only 5 Research One universities in the country with such an office. It is, to me, incredibly important, obviously as a signal, but I'm not a big fan of signal gestures, but as a matter of substance, to really create a central office whose sole purpose is to make sure that we are making interdisciplinary inquiry, research, teaching, program development easier and not harder. For those of us, I think many in this room whose work is inherently interdisciplinary, you probably know that institutions everywhere talk about their support for interdisciplinary and indeed transdisciplinary work. But when the rubber meets the road, there are barriers that appear, some real, in fact, some perceived, but the perception is enough to derail as well. And my goal in creating this office is to have a leader, a vice provost, and a team who go to bed every night thinking about those barriers and how to break them, and wake up every morning thinking about it and spend their days doing nothing but thinking about it. As it turns out, I do that. I just don't have the time to devote to that anymore in the way that I did in prior roles that I held. And that's because I like to say that years ago I had to give a job talk, and the job talk was about my vision for a particular institution. And for reasons I can't fully explain, because, well, I can't explain. I was the only candidate in the search. And as a result, I was the most nervous I've ever been. Because when you're the only candidate in the search, if you don't get the job, it wasn't that there was a better candidate, it was just you. There's nothing else. By the way, I did a lot of work in the Soviet Union in the 1980s, so I refer to that as a Soviet-style election. I gave this sort of, frankly, rambling 45-minute speech. I promise not to do that this morning. The next day, it was a very full couple of days of meetings. About midway through, I had a meeting with all the endowed professors in this particular unit, and they asked me to sort of, elaborate on my vision. And I said, I'm going to actually do the inverse of elaborating. I think I can capture my full 45 minutes in a single word. And that word was, and it's stayed with me ever since, that word was and is impact. If we define everything we do by that word, the impact we have on and through our students, the impact we have through our research, and the impact we have on our community and communities, local, state, national, global, we're doing extraordinary work. And that really is the mission of higher education. I think it's the value proposition of higher education. I think it's why there's been an erosion of trust in higher education, because we've gotten away from that impact. And I think impact happens at that intersection of disciplines, across disciplines, and not in a single silo. And so this conference, as you all know, is literally the epitome of that kind of work. So that's why I'm very sincere when I say that it would be awkward because I'd probably want to sit in the chairs and just listen, but I would sit with you here. I would be envious, but I would sit with you here, and will in the future be here. And I just am sorry that I'm going to head out, but I'm really grateful to Rudy, to Nick, to Vincent, to everyone who's helped make today possible, to the teams who work very hard to make days like today possible. I'm excited to be part of this going forward, and really grateful to all of you for being here. I want to thank the panelists. I want to thank all of you who are here, and I really encourage everyone, particularly our students who are here now, and hopefully as others come in, to really engage fully, to ask questions. One of the things that that I'm really hopeful for is that we'll create. Last night I had the unique opportunity to lead a conversation with the author Walter Isaacson, and a few of you may have been there last night. And there was really one theme that he threaded through the night, and then he thinks about through all of the different extraordinary individuals, some living, some long deceased, who he's written about. And that singular question is the question of curiosity. He said that was the singular defining feature for him. If you think about Da Vinci, or you think about Elon Musk, or you think about Steve Jobs, Benjamin Franklin, Albert Einstein. And he had this very cute, he said one of the things that he loved about Da Vinci, in the 7,000 pages of notes that he looked at, was Da Vinci would write little notes and questions in the margins. And he said one of his favorite things was that for one of his paintings, Da Vinci had posed the question, what does a woodpecker's tongue look like? And he thought, why does that matter? Will have no representation, but that is the question. At his heart, that's a question of curiosity. It may not be relevant to that. Einstein asking, why is the sky blue? Da Vinci asking why, over generations asking these questions that one asks. So today's conversation is really a conversation about curiosity, and for our students, I like to share that is hopefully at the heart of everything that you do in your inquiries as undergraduate and graduate students. And that's something that we as faculty hope to motivate and hope to facilitate, and as leaders hope to support as well. So again, I just want to welcome you all. Thank you all for being here, and wish you a wonderful, wonderful day together. Thank you.
Thank you, Provost Samus. This is a great launch for the conference, with this concept of impact and also curiosity. As you heard, this is the 10th anniversary of this forum, and it's a major milestone for us. Over the decade, this has emerged as an important platform for exploring how new technology is shaping the city, but also for speculating about the future of our cities. And from the beginning, the goal has been to bring academic research and industry innovation here under the same roof to inform one another. So it functions like an expo for new technology, but also a venue for critical discussions about their broader implications. And the goal has never been technology for technology's sake, but rather understanding how the new tools can help us address the major challenges of the 21st century, but in thoughtful, ethical, and responsible ways. This year is also significant, and you heard it from the Provost, because the conference continues to evolve institutionally. What began as a collaboration between the School of Architecture and the Frost Institute of Data Science and Computing now is welcoming the College of Engineering. And we are very happy that we have now this new collaboration, because all the questions we talk about are at the intersection of design, data science, computation, but also engineering. So we thank Dean Omachunu and the college for joining us in this project. And of course, the conversation continues to evolve, and especially now with the rapid development of AI, advanced data analytics and decision intelligence, which are really reshaping all these questions that we have put on the table a decade ago. So this 10th edition is both an opportunity to look at how far this conversation has gone, but also where it may be heading in the future. I would like to thank Professor Sarbeswar Praharaj for his role as academic advisor and the group that makes this conference possible year after year. Evelyn Cruz, Francis Garcia Balbin, Helen Janelle, Justin Gamage, and many others who put all this together for us every year. Thank you all for your continued dedication. You really do a great job with this. And finally, I'm pleased to introduce this year's conference chair, Professor Minghui Cheng, who has done an excellent job in putting the program together and defining, sharpening the theme and the focus for this year's edition. Minghui will tell you more about the program and the sessions ahead. Thank you, Minghui, for leading the conference. And again, thank you all, and especially our guest speakers for joining us today.
Good morning, everyone. Thank you for the Provost and for the Dean for the very good kind introduction. So my name is Minghui Cheng. I'm the co-chair of the conference this year. And this year's theme is 10 years of smart cities, lessons, leaps, and the road ahead. Our discussion this year will center around 3 critical pillars: transforming the built environment to better sense and respond to humans' needs, and advancing public health and well-being, and strengthening community resilience against natural hazards. So this year's event will kick off with an industry expo in the morning, and then followed by keynote presentations and panel discussions in the afternoon. And without further ado, let's begin our industry expo. Our industry expo is hosted by Mr. Raimundo Rodulfo. Raimundo joined the city of Coral Gables in 2004 and currently serves as Chief Innovation Officer and Director of Innovation and Technology. He leads strategic planning, co-innovation, oversight and management of citywide IT operations, infrastructure and smart city initiatives. Under his leadership, the city has built a resilient smart city technology infrastructure with a collaborative innovation and research ecosystem, and has been recognized with over 40 national and international awards. So there is a long list of awards, and I'm sure I cannot read all of them within this limited time, but it's a great honor to have him as our host. We believe he will provide a unique perspective on the technology that will be showing the progresses of smart cities in the past 10 years. And let's welcome Raimundo.
Thank you, Professor. So, good morning, everyone. So, it's a great opportunity to be here for the 10th anniversary, I guess, of this great meeting of the minds. Thank you for the university, always with the partnership on innovation and smart city programs with our city. In my team, the Innovation and Technology Department, we work with faculties, with researchers on joint research. We get interns from in our Smart City Research Laboratory. We also participate as guest lecturers, and we do a lot of things together that is part of that triple helix model of government working with academia and with industry to cross-pollinate and also improve quality of life in our city, this city where we are all together today. And I invite you to visit our booth, where you will see 4 experiments that are being led by staff in my Smart City Research Laboratory. We get interns from University of Miami and other institutions, so you will see some of those applied AI and IoT and geospatial analytics. type of projects, and you will learn a little bit about what we do in the lab in collaboration with the University of Miami and other institutions. So I have the great pleasure and honor to be the MC of this session. We're going to have 9 innovators, 9 teams that are going to show us amazing solutions that are tackling challenges and real-life problems. So because we have 90 minutes and each presenter is going to get approximately 8 minutes, including Q&A. So time is of the essence, so I'm going to get right to the program right now. So what we're going to do, we're going to have a little bit of Q&A and after each presentation, and we are going to have some slides that are going to be changing for the presenters. And let's start with, let's welcome our first presenter. So Mr. Brian Brooks. Is Brian here? Hello, Brian. So Brian is the Executive Vice President of AI Waysian. Before this role, Brian established and led the research and innovation team at Sound Transit, the Seattle region's largest transit agency, among other executive roles and accomplishments. So he will present AI Waysian, which is AI and edge computing solution for safer and more efficient transportation. It's a topic that is close to our heart in Gables, where we have a lot of AI-powered traffic management solutions. So welcome.
You hear me? Okay, thank you. So I'm Brian Brooke. I'm with AI Waysian. We are a Seattle-based company. Our co-founder is Dr. Waysian. He actually received his PhD in transportation engineering from University of Florida, so he knows the area here. We provide cloud and edge-based AI, video analytics, equipment and platforms to improve safety and efficiency in transportation systems. What you see there is our all-in-one device that we generally deploy when we're not using existing cameras to capture the video. We're a spin-off from a University of Washington transportation lab. We spun off a few years ago. And since then, we've won several SMART and SBIR grants to further develop and deploy our technology. We've also won a number of awards for improving transportation safety in our deployments to date. Whoops. Our all-in-one unit that you can, do we have a picture of it up there? Oh, you can't see it in there. Anyway, the one that you saw earlier, the all-in-one roadside unit combines video and environmental sensors with powerful GPU-based edge processing and custom-trained algorithms to extract and communicate relevant data from the sensors in real time. It performs tasks such as count, classification, and trajectory information for all road users. That includes all 13 FHWA vehicle classes, bicycles and pedestrians, micromobility, a full breakdown of all those details of the road users. It can provide near-miss, hazard, and anomaly monitoring for real-time alerts or recording. We can connect to signal controllers to provide real-time signal intervention for things like pedestrian walk extension for slower moving pedestrians to clear the intersection, dynamic right turn on red where that's appropriate, or red light dilemma zone signal adjustment. There we are. Okay, so let me make sure we have, yes. Okay, so there we see some images from our data analytics platform. So the data that we collect from our sensor network is sent to a dashboard, which can provide device management for the traffic management center, real-time alerts for those things that they're interested in, current and historical data analysis, and captured video of key events that they decide they want to record video of. So we currently have deployments in 10 states, about 15 cities, and other municipalities, counties, that sort of a thing. We are expanding, including right here in Miami-Dade County. So in partnership with the Miami-Dade County Innovation Authority, and big shout out to that organization, and Miami-Dade County Transportation and Public Works Department, we will be deploying some units here to work on some of the county-driven priorities. So with that, I will encourage folks to come and visit us. We have a booth there, so we can find out more. And I look forward to meeting you all and talking with you.
Thank you, Brian. Very thoughtful presentation, and it touches a lot of challenges that we experience ourselves in smart cities. So do we have any questions from the audience for Brian? Yes.
How do you deal with, are there privacy issues you have to deal with in terms of what's being recorded and things like that?
Oh, that's a great question. So our particular equipment is sort of privacy forward. We don't intentionally capture images of faces. Generally, we're at a distance, that we certainly don't do facial recognition, and the image quality that we capture is such that that's not going to be a concern. We don't capture license plate numbers. In general, the video analysis is done at the edge, and the only thing that's transferred back, unless there are events that they really want to capture, is going to be data about what's actually going on there. The vehicle counts, classifications, that sort of a thing, completely anonymous information, but the key points, the useful information that can be used for the safety analysis or real-time activity. Yep.
Thank you, Brian. So we are going to have now our next presenter is going to be Derek Duzoglou. Is Derek here? Hello, welcome, Derek. Good morning. So Derek is the founder of D-Squared Engineering. He's a mechanical engineer, sustainability strategist. He is the chair of the Sustainability Advisory Board for the village of Key Biscayne, serves on the Industrial Advisory Board for University of Miami's Department of Mechanical and Aerospace Engineering, among many other roles and accomplishments. So he's going to present his solution for a resilient infrastructure pod, delivering decentralized, containerized infrastructure for resilient communities. So want to hear about that, especially with the upcoming hurricane season coming.
Beautiful. Thank you so much. Good morning. Good morning. All right, so thank you for that intro. This picture speaks volumes to me. Just to give you a little bit of a background, this was in 2011, post-earthquake in Haiti. And I took a trip down there because we organized through a martial arts school that my family owns to send a ton of clothing to the orphans that lost a lot. And we had this beautiful tour of this facility that was built by a nonprofit. And when we went in, you see these beautiful houses that are painted on the outside, but you walk into the house and there is not one piece of furniture. Inside is not painted, there's no plumbing, there's no electricity. So great, you have a structure, but there's no core to sustain living or help to elevate the quality of life. So when you look at the problems that they're experiencing, and again, our big focus and passion is helping these underserved and remote communities, is that water is a lifeline, and most of these people don't have access to it. The numbers are staggering. Nearly 40% of the Earth's population lives within 100 kilometers of the coast. And a lot of these people experience water scarcity and water stress. So what we did is we said, okay, how can we leverage technology to change that, to help uplift people, to give them opportunities? And that led to this idea for what we refer to as Blue Current. As it was mentioned earlier, I'm a mechanical engineer, and I've dealt with the last 8 years of my career in modifying shipping containers. I'm a big fan of Legos. Ever since I was a kid, having that modular approach always spoke to me. So, any way that we can decentralize and offer mobile solutions, I'm all for it. Now, tying in the sustainability component, what we've done is we've created this resilience pod. It's in a 10-foot shipping container. You have collapsible solar panels, which essentially open and close like an accordion. And then you have desalination, which is producing roughly 1,800 gallons of fresh water per day. Now, that's life-changing. One of these trips that I did take to Haiti, we were out in front of this orphanage, and there was a kid that woke up in the morning, and they came out, and they went over to the cow. I said, to the lady, what is that kid doing? They're preparing breakfast. So I didn't say anything, and I just watched. This kid didn't have water, didn't have food, took the udder of the cow, squeezed it into the dirt, mixed it, and that was breakfast. So when you look at situations like that, to take a technology to really have the opportunity to uplift somebody, to elevate their quality of life, and I'm going to be speaking later on the health and well-being panel, you kind of eliminate a lot of those risks with the healthy water sources. And that's one of the things that we're looking to do and change with this technology. Oh, let me go back. That's it. I only had 3 slides. I'm all about efficiency.
Thank you, Derek. Very touching presentation and an ingenuity that is applied to quality of life issues that we all relate to.
Appreciate
So
it.
any question from the audience, please?
What is your source of water? Where do you get the ocean?
Yeah, correct, the ocean. So we have the ability to plug and play and change depending on where the source of water is located. We can do a reverse osmosis, traditional reverse osmosis for a lake or a river. However, we feel that the most stressed communities tend to be the ones that are on the outline closer to the coast. So in this specific case, we're dealing with a small-scale reverse osmosis system for desal, for the ocean. And just a little background, my first job out of college was designing the mechanical systems on yachts. So I've been dealing with these desal systems for the past 20 years, so I kind of took that and put it in a little bit of a different context.
Thank you, Derek. I appreciate it. Any other question? Yes.
Hi, thank you for your presentation. I'm curious, with that 1,800 gallons per day estimate, how often do you have to remove the excess salt concentration?
So one of the things, again, this is, right now we've done all the engineering for this. I've built individual systems that include battery, that include water purification. For this specific setup, we haven't built it yet. This is, again, pre-concept. We're a startup in this with respect to this. They're pretty robust systems. So typically what you go through is you go through a process, maintenance process once a month in order to clean out those membranes and make sure everything is flushed. The salt content left over from a small scale facility like this is not massive. Doesn't really have any adverse environmental effects. And if there is a zone that is specific to maintaining quality, we have a program in place to assist with that.
I have a quick question on the electrical, on the nanogrid. So what is the consumption of this unit?
So there's a lot of research that went into this. A lot of the desal units that you look, and when you look at traditional reverse osmosis versus desal, there's a massive energy draw with the desal compared to the reverse osmosis. So we looked at over 25 different systems, and we found this one specifically because within the 10-foot container, we were able to house the solar and the battery for this to be completely off-grid. And I don't think I touched upon that, and thank you for bringing that up. The goal was that you drop these into these communities, and keep in mind these people have nothing. So for you to offer the opportunity where they can provide water completely off grid, and then have the flexibility to switch back and forth between providing water, or if they need power, they can do that with this unit. This one in particular has 10 solar panels, so it's about a 5.5 kilowatt system. And obviously energy consumption with those small communities is relatively low, so there's a lot of possibilities for them to provide what they need.
Impressive. Thank you, Derek.
Thank you very much.
Let's now welcome our next presenter, Dr. Jianyu Lee, Assistant Professor at the University of Miami's Department of Mechanical and Aerospace Engineering. Welcome, Dr. Lee. Her research centers on the development and application of low-cost environmental sensing technologies for air and water quality monitoring, something that is close to our research in our Smart City Research Lab, because we need to scale our network of physical systems in a way that is cost-effective and sustainable. So yes. Thank you. We welcome to your presentation.
Thank you. Hello, everyone. My name is Jianyu Li, and I'm from Mechanical and Aerospace Engineering. Today, my talk is about low-cost environmental sensing and technology for air and water quality monitoring. So I will start with questions we know and what we don't know. If I ask today whether we need to bring an umbrella, possibly that's a pretty easy question to answer. What you will do is you will pull your weather app. You will check, okay, whether there will be a rain in the afternoon, right? And also you will combine with your normal observation, like whether it's a rain season or it's a dry season in Miami. That helps with your decision too, right? So this kind of relies on our weather app is pretty good at predicting the weather data. And this is a very classic engineering and science pipeline. So we need to collect the historical data and build a very robust model to model the trend. Then we can use such a model to predict what's going to happen in the future. Right now with AI, machine learning and artificial intelligence, our model ability has been improved a lot. Based on the data, we are very good at predicting what's going to happen. But what's actually limiting here is we need reliable data from measurements that can support our model development. And our lab is mainly doing about this. We try to provide low cost, low maintenance, and moderate accuracy solutions to monitor the environment. So this can help us answer some questions we don't know yet, such as, is the water we are drinking safe? How is the air quality? How is the air quality in the room? And also how much fertilizer we are wasting. So I will use one example, one research project in my lab to talk about this procedure. I will start with the impact of nitrate. So the excess nitrate in the environment is mainly from fertilizer. So farmers or farms, usually they need to apply fertilizer to ensure the crop yield. And these excess fertilizer usually go to surface water or groundwater with rain. And this is a pretty important issue critical issue in Midwest, where agricultural practice is a very important activity there. And what will this excess of nitrate will do? It will cause eutrophication, harmful algal bloom, causing the death of animals. And also, if they accidentally contaminate our underground water or drinking water system, it has health impact too. That's the reason EPA regulates the water quality, the nitrate concentration, to be within 10 microgram per liter. How can we measure nitrate? So to measure nitrate, I made this one. I call it trade-off triangle. For any measurement currently we are having, usually it cannot collect all three characters. Usually it only collects 2 characters. Some products only collect 1. So that means for a method, it cannot be all like low cost, high accuracy, and low maintenance. For example, for nitrate sensing, for conventional method, this is OTT SUNA method. It's cost around $30,000, and it's not low cost, but it's overall low maintenance and high accuracy. You just need to dip the tip of this sensor, and then you can know what is the nitrate concentration. And then you can also grab samples for wet chemical analysis. And this sample, it's pretty accurate and also low cost. Each sample only costs around $3. But the issue is you need to have a very well-trained researcher or lab mate to collect data and do the web chemistry daily. So our goal is here. We are trying to find a solution that's maybe slightly higher cost, but you don't need a lot of maintenance and can still demonstrate a reasonable data quality and reliability. So with this is a prototype developed in our lab. It's a unit costs around $800 for field deployable continuous measurement of nitrate. So it has a 235 nanometer LED and a photodiode, and another pair of LED and photodiode here. So this, and then we have a flow tube here that has continuous liquid drawing through. So, so nitrate solution will absorb light of 235 nanometer, and is kind of not very sensitive to 275 nanometer. Based on the ratio of these two, one providing the absorption from nitrate solution, and the other one provide a baseline, we can get the continuous measurement of nitrate concentration. And we compared our performance with OTT SUNA sensor, the super expensive one. And from 0 to 100 ppm, from 0 to 100 milligram per liter, we demonstrate R squared almost equals to 1. And our sensor has a RMSE, root mean square error, around 0.67 milligram per liter. That's much more sufficient for majority of the sampling requirement, environmental sampling requirement. So this is a paper we just recently published about this sensing unit. With such a unit, we're collaborating with University of Illinois, UIUC, Erbauer Champion. So right now, the runoff modeling for watershed measurement, they lack a lot of data to provide input. They can use machine learning to improve their model accuracy, but without fundamental data, they won't be able to do it. So that's what we're doing. We are working with them. We propose to deploy multiple of our sensing units to collect the data so they can have a better model with our data. And also we are working with University of Minnesota for an on-site nitrate fixation with closed loop control system. So this decentralized the risk of the supply chain of nitrate fertilizers. So later you will be able to use solar panel to synthesize particles, to synthesize nitrate and then to deploy them for your hydroponic system. So overall, that's what we're doing. So our lab is interested in sensing. So we have the ability for air sensing and water sensing, where for air we can measure PM and the majority of the gases, including carbon monoxide, carbon dioxide, NOx and VOC, and also pathogens. And at the same time, we are doing water sensing too. We develop our own nitrate sensors, and at the same time, this will extend it to phosphorus sensors and also turbidity sensors later. So with our data, we hope to digitalizing our environment, and then they can empower smart cities later for build a higher level structure that can realize closed loop control. Thank you.
Thank you, Dr. Lee. So any question for Dr. Lee? So I do have a quick question. So this is close to the work we do in the Innovation and Technology Department. We have a network of environmental sensors, air quality sensors and water quality sensors that we deployed in collaboration with water scientists. So the challenge is, of course, we all want to be on that sweet spot of that Venn diagram, low cost, high accuracy and low maintenance. So the issue with water sensors that we have, those buoys that we deploy in water canals, of course they are exposed to salinity and to the elements. So how do you see us addressing the challenge in particular for coastal areas and water canals when those buoys that we use today, they are really, they're not cost effective and they are high maintenance. So they are not in that Venn diagram that you see there. So how do you see that evolving in the future for cities like ours that we need to measure water quality?
Yes, I think that's a very important issue in coastal area. We definitely want to have a sensor put in the field, and we don't need to worry about it at all for a really long time. But for water sensing, except these technical details, like especially coastal area, it's a pretty harsh environment too. Like the salt, the salt will be able to deposit there, and also a lot of animals, they will chew the wires and everything. We have met all of them. So I was thinking maybe so we can do two ways. One is the sensor is really low cost. You just put there, later you can directly trash it. You don't need it anymore. Exactly. That's one way. The other way is we build a stronger system, so it's moderate cost, but still very robust that can survive a little bit longer in the field. So that's, I think, possibly will be the two ways to go.
Thank you, Doctor.
Thank you.
We will reach out to you for collaboration.
Thank you.
So we are collaborating with aerospace engineer from SpaceX background. We are developing low-cost air quality sensors today in our lab. So I'm very interested to collaborate with Dr. Lee. So let's welcome our next presenter, Dr. Sivakumar Ramanathan, Assistant Professor at the University of Miami's Department of Mechanical and Aerospace Engineering. Before joining as faculty, Dr. Ramanathan was a postdoctoral researcher at Oregon State University and worked on solutions for the development of low-carbon concrete materials, among many other roles and accomplishments. He will present the Miami Engineering Autonomous Mobility Initiative, or MIAMI. And we see a lot of autonomous systems and vehicles and urban robotics now coming to Coral Gables and all over the place. So we are really interested in your presentation. So thank you, Doctor.
Thanks so much. Thank you so much. So I'm just going to give a quick overview of the initiative that we have here in the College of Engineering. So this was started a couple of years ago. So what I want to say is that this is Miami spelled badly, I guess. So this is, we just try to say Miami in Miami. So this is Miami Engineering Autonomous Mobility Initiative. And this is a university, academia, whatever you want to call that, industry and government collaboration. And we want to transform autonomous mobility. And it's especially important in the context of Miami, primarily because Miami has become one of the test beds for autonomous vehicles. We've been seeing Waymo vehicles right now. And ultimately, at some point, we want to be this. We want to be able to take off from the skyscrapers. We want to be able to land on skyscrapers. We want to have vertical takeoff landing. We want to have short takeoff landing vehicles that would actually help us reduce our commute time drastically. That would help us do short hops very quickly. That would personalize your destinations. So ultimately, this is what we want to be at in a smart city, very Star Wars-esque. And for this, autonomous air mobility is basically the solution, primarily because you have an airport 15 miles away for almost 95% of the country, as you can see this. So this would also help us revive the regional aircraft industry for short-haul airlines, for cargo, for charter flights, and even for rescue missions, especially in the context of disaster recovery, etc. And this is an effective alternative to easing ground transport. I don't know how many of you drove here today. I hope it was not a bad drive. And of course, we will also be able to have rapid responses to emergency services. And most importantly, for smart cities, you'll be able to have the last mile delivery solutions. And this is also particularly of interest for the state of Florida, where you're able to have all those folks in the Everglades that don't have enough connectivity in the event of a disaster. So you're able to kind of provide them autonomous delivery solutions. Right, so the ultimate vision of this is to have alternative energy powered, fully autonomous air mobility and make it affordable by 2045, hopefully. The mission is to have technology invention and have a clear integration into the AAM ecosystem. There are a couple of faculty who work on novel systems such as co-flow jets for advanced propulsion. And we also have a lot of clean energy-based power sources. Folks work on batteries, etc. I myself work on the infrastructure side of things. So if you ask me questions about clean energy or propulsion systems, I may not be able to answer. And of course, for all of this, it is very important to have public acceptance. It's important to have the public aware of the issues, public aware of the technology, etc. So that's one of our missions. And our purpose is to develop essential technologies and enable fully autonomous advanced air mobility and provide workforce development and address specific socioeconomic needs and tailor it to specific smart cities as we need them, right? So we work on, at the university, primarily the research and development and the workforce development side of things. We also have a whole series of industry partners, which I'll talk about in a little bit. So we work on basically aerodynamics and propulsion. This was the brainchild of the previous dean of the College of Engineering, who actually wanted to integrate all these research areas into an autonomous mobility kind of center. So we have aerodynamics and propulsion. We have folks working on sensing and imaging. We have folks working on AI, autonomous route planning, etc. We have a few folks working on sustainable infrastructure, structural health monitoring, vertiport infrastructure, which is a somewhat tricky concept compared to a regular helipad, primarily because you're trying to go for alternative energy sources. Of course, we at the university do workforce education and training. And of course, we also have the aircraft structures and materials that folks are working on. So ultimately, we want to integrate all of this for your friendly neighborhood local aircraft to make this vision a reality, right? So these are basically, at the moment, our partners. We have the College of Engineering leading the initiative with a bunch of folks. So Era Auto is a very interesting person because they have the first AAM dealership in the whole of the United States, and they are in Palm Beach if you guys want to book your vehicles. So Era Auto is here, Eve Air Mobility, Ryder, who are very interested in the last mile delivery solutions. We have folks from the Middle East who are very interested in this technology. It's easier to implement stuff there, so they are very interested in this. So we also have a couple of think tanks as a part of this. We have the Beacon Council support. We've been working with drone delivery companies who actually want to be in the disaster recovery field, etc. We have Whisk, who've been you would have heard about Whisk a lot of late because they've been publicizing advanced air mobility and the partnership with Miami a lot over the last couple of years. Then we have other universities in the state of Florida as a part of this. We're also talking to a bunch of other companies / universities. And we ended up having a partnership with Frost Science. We ultimately want to have that partnership with Frost Science where we're able to have an exhibit where they say, this is the history of aviation, this is where we were, this is where we are now, this is where we want to go. And we operate under different verticals. We have our advanced technology development, we have our operation and maintenance, because all of these components are very, very, very important for your AAM ecosystem, right? And we also want to have public relations, education. We also have to have centers of excellence and work with federal and state groups for this. And these are some of the faculty that actually work on this at University of Miami. We also have the ex-VP of Embraer who retired. So he is one of the folks that's leading the initiative here at University of Miami. And we do a lot of community engagement events as of now, just to gauge interest, just to kind of let people know that, hey, this is something that exists here at University of Miami. And we also have our annual workshops where we end up having folks show up. I just wanted to highlight this vehicle here. So this is from one of the partners we have. These people want to have these, you've seen those bumper cars that bump into each other, right? So they want to have something, but with flying vehicles. I'm pretty sure it's going to be fun, but I know where it's going to end up at. And yeah, happy to take any questions you have.
Doctor. Have a question there?
We're promised that we were going to have flying cars soon. So my question is it really soon now? Are we going to have flying cars soon?
I'm going to give you the politically correct answer. We have a lot of regulatory concerns rather than just having a flying car. It's going to be at least another 2 or 3 decades before it becomes a reality and, widespread.
Thank you.
So the Jetsons are coming, I guess.
Hi, good morning. My name is Samantha. I have a few questions. As we know with the other panel speakers, we have seen how sustainability is such an important factor in this, and also how we are seeing the global economic and political climate when it comes to, let's say, oil and getting fuel. How do you guys think that you will manage this crisis? Also, how will it be able to be sustainable both environmentally and long term? And I think I'll start with that, and maybe later I'll ask you some more questions.
That's a very loaded question. So the short answer is, at the moment, right, it is kind of difficult to gauge energy sources, etc., if you will. So the hope is that ultimately all of these vehicles are battery powered, or they are powered through, they're EVs at the end of the day. But you could raise the question that, hey, where do you get your power source for EVs? Isn't it still burning coal, etc., to charge your vehicles, etc.? For that, we do not have an answer yet. There's a lot of research happening at Department of Energy. So again, this whole ecosystem to become a reality will take a few decades. So at the moment, yeah, you have short hauls. Your range is about, 30 to 40 miles at best with the current battery technology. And as you start working on increasing the battery energy density, etc., you could have vehicles that do about 100, 150 miles-ish, but that's way in the future. We just wanted to be the first people on the ground to actually have this initiative, show that we are thinking about this, we are trying to actively work towards it, we are trying to get our lawmakers interested in this concept, and which is basically why we've started, this initiative at this point. But yeah, your question is very valid, and there are concerns about this, about trying to make this a reality. Yeah. And of course, you also need a lot of, fast charging stations, charging networks, so on and so forth. It becomes very complicated as you go into the logistics of it.
Thank you, Dr. Ramanathan. So we know that innovation goes faster than regulation and legislation. So we are always having afterthoughts after we see things changing and being adopted. Today we have companies like Waymo and Tesla with doing autonomous vehicle presence already and adoption. And we see people actually taking those robo-taxis and systems. But also we have vertiports and eVTOLs across the country, so use cases. So that's happening now. And we were talking about 10 years, 5 years ago, and now 10 years became 5 years. So it's an exponential adoption, and we're going to see it happening. And I guess that the people at the FAA and the DOTs across the countries, they are thinking, how are they going to manage that? So we will have to see a lot of policies enacted in time. So let's welcome our next presenter, Kylie Rocks. She is a PhD student at University of Miami, Department of Civil and Architectural Engineering, and a Department of Defense, National Defense Science and Engineering Graduate Fellow. So her solution is Canopy, scalable coral reef protection against thermal stress. So close to Florida, now we know that there have been widespread coral bleaching events and a lot of concerns about protecting that ecosystem. So thank you, Kylie.
Hello, thank you for the introduction. Good morning, everyone. My name is Kylie Rux. I am a PhD student in civil engineering at the University of Miami. Today, I will be presenting Canopy, which is a scalable coral reef shade. I would also like to introduce some other members of my team, Danielle Behar, Joshua Prabhahar, who are in the audience today, as well as our other teammate, Montel Tuin. This project started out as part of a design thinking challenge that was hosted by the National Marine Sanctuary Foundation in October of 2024. Our team won the overall challenge, and for the past year and a half, we've continued to refine our design, as well as manufacture and test our first prototypes. In the summer of 2023, Florida experienced unprecedented water temperatures, with major headlines reporting temperatures reaching hot tub levels. This led to a phenomenon called coral bleaching, which is caused by the synergistic effects of elevated water temperatures as well as intense solar radiation, turning a healthy, vibrant reef like this into a white calcium carbonate skeleton. Bleaching was witnessed worldwide during this period, and NOAA confirmed this as the fourth and largest global bleaching event on record. And 50% of our planet's coral reefs have already died, with current estimations predicting that more than 90% of our reefs will die by 2050. So why is it important to protect our coral reefs? Well, coral reefs are often referred to as the rainforests of the sea, as they provide many benefits, including biodiversity, medicine, coastal protection, food production, and tourism, all valued at $9.9 trillion annually. In the state of Florida alone, coral reefs provide more than $600 million each year in coastal protection as well as economic activity benefits. And as we look into the restoration market, a total of $1.9 billion has been allocated towards conservation and management of these reefs and associated ecosystems, as well as a projected 10% annual growth of this market driven by the increasing threats to our reefs. So as we work to build a more resilient Miami and South Florida, protecting these ecosystems is incredibly important. So in response, Canopy was developed. Our purpose is to protect coral reefs from bleaching by shielding from harmful ultraviolet rays. This is one of our units on the top right. It is a bio-inspired modular design that is made up of hexagonal shaped units. We have three main components, including the air-inflated exterior, the interior shading cloth, as well as connection points on all diagonals that can be connected to neighboring units. And our current prototypes range from 5 to 6 meters in diagonal. Our solution is designed for reefs with water depths exceeding 5 feet, and then a system as shown here on the slide can be anchored to mooring balls that are pre-existing out on these reef sites. It's designed for daily deployment and retrieval, which is all possible due to the rapid inflation time. And these units can serve a wide variety of end users, including coral restoration organizations, research institutions, government agencies, as well as hotels and cruise lines. So we had our first prototypes manufactured and we received them this past August. We got 2 different sizes, including a 5 and 6 meter size. So shown here is one of our 5 meter units in the Rosenstiel Scientific Diving Pool. Each unit ranges from 50 to 60 pounds, and using 2 valves and electric pump can be inflated in the water within 60 seconds. And then we also have these tension lines that run on the diagonals. This can bear any of the horizontal forces, as well as it also isolates the load from the shade fabric, as well as that exterior flotation. And then our shade fabric, you can't really see it here, but it's actually elevated above the surface of the water, and that's to allow marine mammals to surface, as well as gaseous exchange between the ocean and the atmosphere to occur. And then we also did a control test in the pool. For this experiment, we secured canopy to the center of the pool and deployed a series of data loggers beneath the canopy on either side of the canopy, as well as a separate control line. We deployed them at the water surface, as well as at depths of 5 and 15 feet, and recorded the light from 9 a.m. to 6 p.m. that day. And what we saw was canopy reduced light levels at all depths tested, ranging anywhere from 70% at the water surface to 51% at a depth of 15 feet. And most notable for us is we recently deployed canopy out at Flamingo Reef, which is located about 3.5 miles off the coast of Key Biscayne. This marked a critical next step for our team as we are testing canopy for real-world conditions. Shown here on this slide is a picture of our canopy units out at deployment, as well as this video will walk you through that day. So we first started off at the Rosenstiel Marine School with all units on the board. We then boated out to Flamingo Reef site, where we first anchored our boat to a mooring ball. From there, we started inflating our first unit off the side of the vessel and then pushed it into the water. We continued to inflate additional units, and then we also had Danielle on a paddleboard to connect those units together in the water. For this test as well, we also deployed sensors at a control line, as well as beneath 2 canopy units to again measure shading effectiveness. And again, we did see that canopy units reduce light levels by 64%, as well as reduce temperatures by about 0.5 degrees Celsius at a depth of 10 feet, as well as greater reductions even at shallower depths. So moving forward, our team is planning additional field deployments with restoration managers. These are one of our end users who can provide us real-time feedback. We can then use that feedback, modify our design, as well as actually manufacture the second iteration. And we're also planning for extended reef site testing at a nursery site to continue validating canopy's performance. So here is a QR code on this slide. You can visit our website, learn more about our solution, as well as our design journey. You can also follow us on Instagram, LinkedIn. Feel free to email us with any questions or feedback you may have. And I would also like to thank our advisors, Dr. Purnoy Suraneni and Megan Berry, who is here today. And we also have a booth that my team will be at, so please stop by. We also have some giveaway items. So by protecting our coral reefs, Canopy supports marine ecosystems as well as coastal economies. Thank you.
Thank you, Kylie. Congratulations to you and your team. So a very impactful research for environmental conservation and for our society too. So any question from the audience? Well, I have a quick question. So how do you interact with marine life in those systems? Have you seen any other collateral interaction with the ecosystem besides the intention of the project?
You're talking about like with marine animals or with life in general?
Yes.
Yeah, so I mean, I kind of already spoke about this, but we strategically raise that shade fabric so there's actually no interaction with sea life, which is what we want. We want to be able to protect the coral reefs out there while marine mammals can still live in that area and thrive in that area.
Thank you so much.
Yep.
Thank you again.
Thank you.
Oh, we have a question actually from the audience. Yeah. One of our research lab interns.
Hi. My question is, what kind of material is being used, and how much light does it allow to get through? Because I don't know anything necessary about marine biology, but I believe that light is probably essential also, as well as maintaining a cooler temperature. So how does that kind of work?
No, that is a great question. Thank you for bringing that up. So currently our prototype is made out of plastic, but we are also exploring other alternatives that may be more sustainable or could potentially biodegrade in the environment over time. So we are exploring our options, but we do want to address that plastic, of course, is one of the most durable materials. So if we want something out there for a long period, have a long service life, plastic may be the option for that. And then for your second question, so we're using a shade fabric right now that's about 70% reduces light, whereas this can also change over time. So our interior shade fabric can also be changed the way it is. It's looped in right now to that exterior flotation, so we can actually swap it out whenever we need. But yes, it is important to still allow for some of that light to reach the corals because of photosynthesis that's crucial for coral reefs to survive.
Kylie. Okay, so let's welcome Brian Fried, the CEO of Illuminex AI. So Brian is the CEO of Illuminex AI, and as the CEO, Brian is committed to democratizing the implementation of computer vision and AI applications and cost-effective solutions, solving challenges such as data scarcity and technical integration. Before joining Illuminex, Brian held the position of Chief Operating Officer at Eagle Aerospace, among many other executive roles and accomplishments. Illuminex AI brings infrastructure intelligence for airfields. So we will learn a lot about those AI-based detectors. So thank you, Brian.
Thank you. So I'm Brian Fried, CEO of Illuminex AI. An interesting factoid, if you were to look at the average of this audience, the economic contribution of each of us is about $65,000 a year contributed to the US GDP. And to maximize that contribution, we each have a digital footprint that's approximately 120 gigabytes. If you go to your local airport, you have an airport with perhaps $2 billion in infrastructure out on the surface, contributing $20 to $40 billion a year to the economy. And at one large airport we recently met with, they had less than 10 gigabytes of data on that built world infrastructure from the terminal to the fence. And to me, what that represents is an economic opportunity. Because if for each of us there's value in having an order of magnitude more data that can help to maximize our economic contribution, how much is being left on the table at those airports due to the lack of built world infrastructure? So if you think about what that means, airport infrastructure is built with a 20-year useful life. If we can increase that useful life by only 5%, add 1 year to that, we're adding millions of dollars a year in savings. If you think of the cost of unplanned runway closures, so if there is a pothole or a crack that forms that's greater than 3 inches, they have to pause and fix it. And those unplanned events escalate through the ecosystem, causing upwards of $1 million per unplanned closure. And so what we see as the opportunity is to bring technology to bear on this data scarce environment and to augment the existing processes to achieve improved safety and better maintenance. So how do we bring this to bear? We literally and figuratively bolt on to the existing process. One of the challenges with built world infrastructure, particularly the airport ecosystems, is while many folks would want to think outside the box, they live in a box called a regulatory framework that has existing standard operating processes. And so if we're going to affect those situations, we need to work within those existing operating processes And while we love the idea of autonomous inspection vehicles and drones and robots, the reality is that to affect those airports, we need to physically bolt on what they do today, which is take a vehicle out 4 to 6 times a day to inspect those runways. And what we're doing is we're augmenting those human inspectors. So today, a human inspector will typically write down 1 or 2 items, so observations or discrepancies per trip, because that's all they have time to do and remember while they're driving 50 miles an hour, while they're looking for planes so they don't have any sort of incursion issue. And we can create orders of magnitude more data through automated collection using AI. The second thing we do is we remove the silos of tribal knowledge and human data. So instead of relying on the memory of each of the inspectors, those are logged to the cloud, and now we can do trend analysis, we can create heat maps, and what it allows us to do is simultaneously enhance safety as well as drive proactive maintenance and root cause analysis. The third thing I want to highlight, and I think it's important, is that every good technology starts with an objective, a return on investment. And that return can be financial or social, but if you start with your objective, your product will build to deliver that. And so within the airport environment, there's really 2 key objectives. So the first is, how do we increase the useful life of those surfaces? Water intrusion is probably the biggest risk factor. You have a crack, rain gets in it, you have freeze-thaw cycles or expansive soils, and that's what breaks down that infrastructure. And so if we can identify those cracks early, we can save thousands of dollars through early repairs. The second is reduction in foreign object and debris. So those pieces of runway that break out get sucked into jet engines, they tear them up. $1 to $5 million per incident, depending on the aircraft. And while most aircraft are built to be resilient to FOD ingestion, it also increases safety because every FOD ingestion creates a risk for the passengers. And so as I wrap up and think about what we've heard today, a couple of things I would like you to take away as students or faculty. The first is opportunities are everywhere. We've heard presentations this morning of technology used to address environmental issue, traffic flows, the future of mobility. And what I would say as a CEO of an AI company is my hardest job is I have to say no to 10 things to everything I say yes. And so for all of you out there looking ahead, the future is bright. There is tons of opportunity to solve problems across the built world. The second thing I would encourage, and I mentioned, is I think the biggest barrier to adoption is the operational cost of change. Those existing processes and rules, and the more that you can integrate into what exists and evolve to what you see as the future, the faster we can drive adoption. And the third is that AI as a technology isn't unique. Like every technology that businesses deploy, it needs a return on investment. And if we start our design with that in mind, we will drive adoption at a much quicker pace. Thank you.
Thank you, Brian. Great insight and great advice also from a CEO in innovation and innovative fields like this for tech to market. It's always the big challenge. How do you take an idea, make it at the end something that will have a return on investment? And any question from the audience, please?
Hi, me again. Something that really resonated with me is how you said that implementing this within airports could be done with existing equipment, like cars that are already on, let's say, the runways and tarmac. What would it look like if you actually integrated this with the biggest vehicles that are on the tarmac and the runways, which is airplanes? When they're taxiing, what if, what's the talk with maybe having this sensor integrated to the bottom part of an airplane that's taxiing and maybe manufacturing that way?
Yeah, no, that's a great question. And I think as I look at the future of vehicles and aircraft, what you see is a proliferation of sensors. So if you were to go look at any modern vehicle and deconstruct it, you would find LiDARs, you would find visible light cameras, and a plethora of sensors that you could use to capture things. And similarly, we're starting to see increasing use of sensors with aircraft. So I do believe that the future of built world infrastructure inspection isn't going to be a scenario where we're just strapping cameras on existing inspection vehicles. It's going to be that every vehicle, whether it's an aircraft or a automobile that traverses the airfield, will become an inspection vehicle that will be capturing and extracting data and building up that intelligence we need to more effectively and efficiently manage that infrastructure.
One quick question, Brian. Do you see that also being integrated with air traffic control systems and centralization of control in those spaces?
So, I mean, ultimately, situational awareness needs to be universal. And I think one of the keys, and I often say that, creating data moats is an impediment to innovation. So what I always tell my team is we want to make our data as open and accessible as possible so anyone who can find value from our data can access it and win by innovating faster, not by holding our data close.
Thank you.
Thank you.
Thank you, Brian. Well, our next presenter is Dr. Minghui Cheng, who is the host of the conference. And he's an assistant professor at the University of Miami Department of Civil and Architectural Engineering. He's a principal investigator at the Structural and Infrastructure Intelligence Lab. Big background, I would say that Dr. Cheng, previously he was a postdoctoral associate at Systems Engineering in Cornell University, a member of multiple international scientific committees and tech councils, among many other accolades. So he's going to present CivilBot, an AI agent for structural modeling and analysis. So as we were developing our digital twin in Gables, so we have that challenge that in the city we have old and historic buildings and structures, and of course we have new constructions that they already come with BIM models and Revit files that we can integrate to the digital twin. But the challenge has always been, how can we model those old structures? And we have to use drones and other technologies. So I'm very eager to listen to what you're going to present today, Doctor. Thank you.
Thank you. Good morning, everyone. I'm very happy to be here to present this CivilBot. So CivilBot is a product translated from the research in our lab. Here, in the United States, there are more than 60,000 structural engineers, and CivilBot is targeting at the structural engineer community. And for structural engineers, when we have to, before construction, we have to model and design the structure. So let's use this Miami Freedom Tower as an example. So the engineers need to model and model the structure in commercial software and then design it. However, the structural modeling takes a long time, and 30 to 50% of the time of the structural engineer's time is spent on using commercial software such as SAP 2000, ETABS, Abacus, etc. And this modeling is tedious and time-consuming jobs, and the structural engineers usually need to make thousands of clicks to construct a structural model like this. To accelerate this tedious and time-consuming jobs, so we propose CivilBot. The CivilBot is, there are two steps to use the CivilBot. The first step is the engineers describe the building in text, and then the CivilBot will autonomously generate the structural models. Let's see if it works.
Still spending weeks on structural modeling? With CivilBot, engineers simply describe the building in plain language. Our AI interprets the input, creates the geometry, assigns materials and loads, and automatically generates a structural model. The model can then be opened, modified, and further analyzed in professional software. from text to structure in minutes.
So it's okay without the sound, but yeah. So this speaks that the structural engineer usually takes a long time, and our CivilBot can, the engineers describe the analysis in the plain language, and our CivilBot can speaks out like thousands of lines of codes, and then the engineers can import those codes into the structural modeling software, and then give you a modeling like that. So we can from the text to structure, we can do it in minutes. And let's look at the comparison of the performance. So for structural engineers, if we do it manually by thousands of clicks, this usually for a very simplified structure like Miami Freedom Tower, it will usually takes 5 to 6 hours. But with CivilBot, it will give you the structural model in just like 5 minutes. So it saves 90 to 98% of the structural engineers' times, and it's an increase in efficiency of like 10s to 100 times. So there is another, besides the efficiency, there is another competitive advantage of our CivilBot, that is it's extremely high reliability. So I'm sure you have experienced a lot of hallucinations when you are using AI like ChatGPT. So ChatGPT also hallucinates for structural engineer. So let's see, on the left it's the real structure, and on the right ChatGPT gives you very strange geometry, and each time it will give you a different geometry. So it's very hard to control. But imagine you are a structural engineer, you rely on ChatGPT to do the structural modeling, and it makes a mistake and the building collapses. OpenAI is not going to jail, but you are going to jail. So reliability is always the bottleneck of engineering AI. And our CivilBot is, when we develop the CivilBot, we optimize it to minimize hallucinations. So if we look at the consistency rates, our CivilBot can get to like 90%, while Gemini and ChatGPT is significantly lower than our CivilBot. And we have some pilot developments. We worked with TPES companies. They are testing our CivilBots for some simple analysis of two-dimensional frames. And we also deploy our CivilBot for in University of Miami. So the students in the mechanics class and the senior design class are learning to collaborate with AI to work on mechanics problem and building design. And we are continuing to, we want to look for more users and partners to further test our CivilBot. And with those test cases, we continue to improve our CivilBot and better meet the industry need and the educational need. And that's all for our presentation. So we have a table and booth, and feel free to check out. Yeah, we have a video and a demo. You can come to our laptop and try it.
Thank you, Dr. Cheng. So I have a quick question. As a licensed PE myself, so I am really very hesitant of using AI tools for plan calculations or for drawings, because you always you are the engineer in charge, you are responsible, you are the engineer on record, and whatever tool you use, you have to verify, you have to validate. So what validation and verification tools a licensed PE has today, even a PE or a civil engineer or a structural engineer, to verify, to validate the output of those AI tools today?
Right now, validation of the AI, I think it's a cutting-edge research right now. There are people that are doing research to try to validate that, and I'm sure everybody has experienced the hallucination issues in life. So, and that's what our research is striving for. And when we make progress in the research, I think we can develop better and better products.
A different AI to validate the output of another AI. Mm-hmm. Yeah. Yeah. Question from the audience? Yes, sir. Let me give you the mic here.
Hi, thank you for your presentation. I'm curious, with your system, does it allow for the inclusion, or does it account for different structural members with different structural properties?
Yes, we have developed that. You can, as long as you can describe it in in language, like this member has this properties, this member has this property, this member belongs to these locations, we can accurately input into the structural model. So we have stress tested it.
Okay, thank you. And in regards to that, does it allow for corrections to be made after the model is generated, if there was some form of hallucination?
Yeah, that's a very good question. And technically, this in academia term, this is a multi-turn AI. So it's a very difficult question, and we hope that as we get more and more use cases, we hope that we can address these issues. Multi-turn is difficult to do.
Thank you.
Thank you, Dr. Cheng. Other question? Yes. Let's go this way.
Hello, thank you for your talk. I'm very impressed by Civilbot's performance compared to ChatGPT. So is this an in-house trained model, or you still call this open source, this model as the backbone and then do like verifications, editing like that?
Yeah, that's a very good question. So for our university, we have very limited resources, so we cannot rely on ChatGPT or Gemini or Cloud. Those very big models, they are expensive to train. So we rely on cheap models like Llama. And we train Llama to get to a very high accuracy and high reliability. And we expect that if we transfer the technology to Cloud, Gemini or GPT, we can significantly improve the performance. And in research, we feel that training on better models is much easier than training on a worse model like Llama. Yeah, I think checking, it's a very good question. I think checking and verification seems it's more difficult than just training it to do the modeling from scratch. So this is, I think, a technical challenge for the academia.
Thank you, Dr. Cheng. So our next presenter is Egea, founder and CEO of EG3A. Eddie is founder and CEO of EG3A, an analytics advisory and architecture firm specializing in healthcare, public safety, and civil infrastructure across Florida, Puerto Rico, and the Caribbean. He has led major initiatives for the University of Miami Health System, University of Puerto Rico School of Medicine, Nicklaus Children's Hospital System, Miami-Dade Aviation Department, City of South Miami, Town of Bay Harbor Island, and the U.S. Department of Veteran Affairs, among many other leadership roles. So thank you, Eddie. The floor is yours.
Thank you, thank you. Can you guys hear me? All right, well, let me start with a quick question. How many of you are already thinking about lunch? Okay, good. Another question. How many of you, whether you're a researcher, student, or private sector, aim to be disruptive or innovator in everything you do every day? Show of hands. Okay, wonderful. Good, there's a good amount. Second question. How many of you are aware of the Consolidated Appropriations Act of 2026? All right, no one. I'll get to that in a moment. So let me move forward. Back in 1989, I got a phone call from my parents saying, we know you're at school, we don't want you to worry, but your mom has been diagnosed with cancer. I'm like, wow, this is big time news. This is disruptive to our family. So I called my mom and I said, how are you doing? She says, I'm doing fine. It's just the fact of going from building A to building B to the clinics to the oncologist to therapy is a hassle. So I made it my mission to study healthcare facility design and planning and humanize the experience of the patients. Well, Long story short, I spent 30 years involved in the planning and design of healthcare facilities, aiming at making that space, making that environment, the hospital, as complete as possible and as humanizing as possible. To my surprise, everybody's surprise, we got hit by a huge hurricane in 2017 in Puerto Rico, wiping out most of the infrastructure. And Miami is not foreign to that risk as well. So I started developing an idea, a concept for the drone-powered hospital, which you can later Google, and you'll find it on The Scene magazine and several other publications, in which the concept was based on drones delivering anything from medications to food to equipment right to the patient's room, to the inpatient room of the hospital. This evolved into a program for a prototype hospital that allowed the hospital to have a smaller footprint. You will not rely as much on the materials management department, on the food preparation department, allowing hospitals to be more nimble and lean and be implemented throughout other parts of the city with a lower budget. Well, my second question, which was about the Appropriations Act of 2026, is a reaction to another thing that changed the way or disrupted the way we do things, COVID. So the government allowed for a regulation that would open the opportunity for hospitals to allow patients to be taken care of at home. So COVID's happening, hospitals are at capacity, there's more patients knocking on the hospital's door, but some after you triage them, you determine that some of those patients can go home and be taken care of. So this notion or this presentation is based on the fact that we are, rather than putting everything at the hospital is being broken up into several components that are scattered throughout the city. Now with the progress of this act and the invent of telemedicine, you can have some folks have direct contact with someone from the healthcare sector, a clinician, from the comfort of their home. Be it through a drone that can deliver the equipment, medicines, or supplies, mom and pop who can be at their house, in a suburban part of town, can have right on time access to care. And as some of others mentioned here today, the introduction of autonomous vehicles like Waymo can also facilitate that connection between the patient and direct care. I've been recently working with the city of South Miami and the town of Bay Harbor Islands, which followed an engagement with the city of Miami Beach in their new real-time information center. And at this location, we're able to monitor through cameras and sensors everything that happens around the city and deploy drones for the surveillance. Why am I mentioning that? Because as we move forward with more drone-powered healthcare, we have to partner up with local government and local jurisdictions, because someone has to be the hub, someone has to monitor all that air traffic. So you will be seeing more and more robust municipal and county facilities for emergency response that not only monitor safety, but also are going to expand in the role of care and healthcare. That's basically it in a nutshell. Any questions?
Thank you. Thank you, Eddie. This is a great example of human-centric design and really addressing a real challenge that we all face.
It is continuing to evolve.
Yeah. Thank you, Eddie. Appreciate it. Well, this concludes our lightning talks of the Expo. So let's give a round of applause to all the great innovators that presented today. Thank you all so much. Thank you.